All right. In response to Michael's question, so the question is, here's the function. Find the inverse function and determine the domain of the inverse function. And there was a confusion as to why the domain is not all real numbers. So if you have this equation here for y, and then you solve for the inverse by doing, first of all, changing the x and y. Some people solve first and then switch. Some people switch first and then solve. I'm going to switch first and then solve. Oops, did not mean that. Oh, well, it's okay. That's an x. And so x squared is equal to 2y minus 5. And then you divide by 2 both sides. Y, which is f inverse of x, is equal to x squared plus 5 over 2. Question is, if that's the function and it's defined for all x, then how come the domain is not from negative infinity to infinity, right? Because you look at this function here, you don't see anything that says the domain should be restricted in any way. Here's why the domain is not all of it. If you look at the hint in the homework, it says look at the range of the function f(x). Let's see. Let's take this and type it in. Y equals x squared plus 5 over 2. Well, so yeah, so that's your x squared plus 5 over 2. And it doesn't look like the reflection of the original function, right? So let me put in the mirror. A function and its inverse are supposed to be mirror image across the 45-degree line. And these are not. Okay, this part is, but there's no image here. Where's this part? The image of this branch would have been here, but it doesn't exist. So we cannot have that entire parabola as the inverse. We can only have like whatever half parabola that is the mirror image of this. So we're only allowed to have that half, and that half only starts here at x equals 0. So let me put that in. If I only put in the part that x is greater than 0, then yes, I do have the mirror image. If you tilt your head 45 degrees and you look at it, then you see that they're symmetric. So you're thinking, well, that's kind of tricky. How am I supposed to figure that one out? Well, remember, anything having to do with x in the function becomes y in the inverse. Anything having to do with y in the function becomes x in the inverse, right? That's even reflected in the method of doing it, where we switch the places of x and y. That's why the question says to look at the range function f. So the range of f is only from this point up, y greater than or equal to 0. Then that tells us that the domain of f inverse is going to be the same thing, except that x and y switch places. So instead of the range being y greater than or equal to 0, then over here, for the inverse, the domain is x greater than or equal to 0. Okay, anything having to do with x for the function becomes y for the inverse. Anything having to do with y in the function becomes x in the inverse. So range has to do with y in the function becomes domain and having to do with x in the inverse. So yeah, that's why you cannot get domain from just looking at this expression here. That won't tell you what the domain of the inverse is. You have to look at the range of the original function. All right, hope that helps.